Now we're going to start a study of triangles. And just imagine you have three non-collinear points, okay? And you connect those points with each pair of points you connect with a side, okay? So you get three sides and three angles formed. You get this angle, this angle, this angle, and then three sides. That's what we think of when we think of a triangle, okay? Because now you all know what a triangle is. But what we're going to do is we're going to look a little deeper into triangles. First thing, we're going to classify them. So we think of the different types of triangles. Like, for example, let's suppose you have a triangle and all three sides have the same length. Okay? Well, then we call that an equilateral. Okay? Now, so that's an equilateral right here. Now, if all three angles are equal, we call that an equal angular. Okay? And down here's an equal angular. Okay? So if we're talking about all three sides being equilateral. If we're talking about all three angles being equal, we call that an equal angular. Okay? Now, if we have two sides are the same length, okay? Two sides are congruent. Then we call that an isosceles. And here is an example of an isosceles. You see the two sides are the same length, okay? Now, that's at least two sides are congruent. You could have three sides are congruent, but as long as you have at least two sides congruent, we call that an isosceles. Okay, now, a scalene triangle, no congruent sides. Okay. A scalene triangle has no congruent sides. So we're just learning some language here. Scalene triangle, no congruent sides. Now, an acute triangle, it has three acute angles. Okay? The three angles of the triangle are all less than 90 degrees. We call that an acute triangle. Now, that's in contrast with this obtuse triangle. The obtuse triangle has one angle bigger than 90. Now, it's not going to have any more than that. It's going to have an angle bigger than 90. And we'll talk about why it can't have more than that later. But an obtuse triangle has one angle bigger than 90. An acute triangle has no angles bigger than 90. And then, of course, you have the right triangle, which you have an angle equal to 90. And we always denote the angle equal to 90 with a little square thing here. That angle is 90 degrees. Okay, so those are the classifications. Now, when we're talking about a triangle, for example, we've got these angles, and let's talk about this angle A here. If we're talking about an angle A, notice that it's got the two sides that make up the angle, this side and this side. Those are the two sides that make up the angle. We call those the adjacent sides. And the side opposite then would be opposite, the opposite side. So we have the adjacent side and we have the opposite side. Okay. Now, look, there are a couple of triangles that we have special names. For example, the right triangle. When we talk about the right triangle, notice we refer to two basic types of sides. We've got the hypotenuse, which is the side opposite the 90-degree angle, and then the other two sides are called the legs. Okay, so we have the legs. Now, that's with a right triangle. So we're learning language here. Now, if we go over here to an isosceles triangle, the two sides that have the same length, we call those the legs, and then the other side, we call that the base. So here's the base and here's the length. So up here you can see the, I said length, leg, okay? So these are the legs and this is the base right here. Okay. Okay, so I drew another triangle down here, and I want to point out some things to you to further define what's going on with these things. Notice that this triangle, I have the 3 angles inside the triangle in blue. Those are called the interior angles. Okay, so interior. So in blue is the interior angles. Okay, so let me write this, interior. Okay, interior angles. Okay, and then in pink we have, surprise, exterior. Okay, whoops, let me do this. Let me get the pink here, exterior. Okay, exterior. Exterior angles. Now, notice that the way I get these exterior angles is I extend out a side. So think about this. Think about, what if I just took this side right here and just extended it out like that? Well, you notice what I get. I get an angle right here. I get this angle. Okay. Now, if I extend the, now notice that, well, let's just go ahead and work around here. If I take this side and extend it out, okay, I get another exterior angle. I get this one, right? And then if I take this other one and extend it out, just extend this out, and I've got them extended out here in red, you can see. I get another angle, this one. Now, you might say, well, how did you choose those angles? Well, notice you get two exterior angles. I get this one, and I get this one over here. This is also an exterior angle. Okay, this is an exterior angle, and so is this one. They're congruent though, notice. They're congruent. This is an exterior angle here, and so is this one. So when you extend these sides out, what you get is you get these exterior angles, and these angles consist of the extended side, one extended side, and then another side. Okay, so notice this angle up here, it consists of the extended side and then another side. This angle here is also an extended exterior angle, and it consists of the extended side and then another side. Okay. Yeah. Now you notice that this angle here, this one right here, and this one right here are supplementary. This angle here and this angle are supplementary. Okay. This angle and this angle, supplementary. So these things, these exterior angles, are supplementary to the interior angle that they touch. See, this pink and this blue, those measures add up to 180 because they're part of a vertical angle. Okay, so you can see every time you extend one of these sides, you get 2 congruent exterior angles. Okay, now let's move on down here and talk about a couple of theorems. One is the triangle sum theorem. Now let's just think about the triangles. Let's just look at a triangle here. I'm going to draw one, and okay, so let's see here. Just draw a triangle. And I'm going to notice that, I can extend this line out a little bit, extend this line out a little bit, and then extend this line out a little bit. Whoops, that didn't work out. There we go. Okay, and extend this out a little bit. So see, I'm taking this triangle I did work with, I just drew, and I'm adapting it a little bit. Okay, I'm extending everything out. Let me make this a little better down here. Okay, a little better. You deserve better. Okay, now I'm going to do this. I'm going to make a line up here. I'm just going to draw a parallel line, parallel to this thing down here. In other words, let's call this L, and let's call this line down here N. L is parallel to N. Okay, now I just drew that in there, and you can see, yeah, I could do that. I could draw a line like that, no problem. I mean, you can always draw a parallel line. You can construct one. We haven't talked much about constructions, but you could construct a parallel line. Now I'm going to do this. I'm going to label these angles in here. I'm going to label this angle 1, this angle 2, and this angle 3. And I'll label this angle here A, and I'll label this angle B. Okay? Now, I haven't done anything wrong. I've just done some labeling. Okay? So nothing fancy. Let me move this out of the way a little bit. Okay? Now, what I'm going to kind of illustrate, I'm going to kind of prove something to you. We have been doing these two-column proofs, but let's just see if we can argue through and not have a two-column proof, just kind of prove it in a paragraph form. Now, one of the things we know is this: the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, we know that that equals 180 because they form a straight angle. And this is angle addition, right? We know that this angle here, this angle, is 180 degrees because it is a straight angle. So I'm going to say because they form a straight angle. They make a straight angle, okay? If you add up all those, and angle addition, that sort of thing. Now, we know this, that the measure of angle 1 is equal to the measure of angle A because they're alternate interior angles. Because two lines cut by a transversal have alternate, because two parallel lines cut by a transversal have congruent alternate interior angles. Congruent alternate interior angles. Yeah. Now, in the same way, likewise, the measure of angle 3 is equal to the measure of angle B. So, by substitution, we have that the measure of angle A plus the measure of angle B plus the measure of angle 2 equals 180. Yeah, now you realize what that's saying. See, because up here we said the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180. And we already said angle 1 and angle A are the same. Angle 3 and angle B are the same. So we have that the sum of the measures of a triangle are always going to be 180 degrees. Yeah, there we have it. Okay, now, the next thing I want to talk about these exterior angles. So look, I've got a triangle here, and notice the measure of angle 1 plus the measure of angle ACB is equal to 180 degrees. Yeah, because angle addition and also you have a straight angle there. This right here, this is what we call a straight angle. And that straight angle is made up of angle 1 and angle ACB. Also, the measure of angle A plus the measure of angle B plus the measure of angle ACB equals 180. Because that is what we just discovered up here with the triangle sum theorem. Okay? Ah, is that so? So, therefore, by transitivity, I should call it transitive property. I think in the past videos I've misspoken and call it transitory property. It's the transitive property. Okay. Therefore, by the transitive property, the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. In other words, these these exterior angles are equal to the sum of the opposite angles. Yeah. Okay. Now, you look down here, you've got an assignment where, we explore some of these things. Okay. Yeah. Let me know if you have questions.